Okay, this is chapter 1, part 3. We left off last time talking about reliability and validity, and this time we want to cover the specifics of validity. Again, this has a tendency to get into the weeds, so I'm not going to take it too far other than to just introduce the concepts and we'll just keep it basic. The first topic we want to talk about is face validity. And face validity refers to the degree to which common sense indicates a measure captures what it's trying to capture. So common sense are the key words there. That you look at a variable, and to somebody who has some common sense, it it seems, at least on the surface, that to be measuring what it's supposed to be measuring, what you're trying to measure. So if I ask you on a survey, a questionnaire, how happy are you these days? And I'm trying to measure happiness. Well, you might say, well, you're asking them what you're after, and I don't see any reason why that shouldn't validly measure, um, what you're trying to measure, at least on the surface. Now, you could go deeper and say, well, I wonder, what if people are really sad and depressed? Would they kind of be, some people be kind of unwilling to admit that they're not doing so well? They're kind of down. So you could dig deeper and maybe run into some questions, but at least on the surface, it seems like it's okay. It seems um, like it's capturing what you're trying to capture. So it's just a common sense uh, view. Judgment would be another way of you use your judgment to tell if it's a good variable. Now, the rest of these are a little trickier, so bear with me here. Criterion validity refers to how well a measure correlates with a well-established measure of the same phenomenon. For example, self-reported age and birth certificate records. So you could say, you could wonder, maybe you were doing a study where you're wondering if people were always honest and accurate about telling you their age in an interview. Maybe you suspect that some people might kind of bend the truth a little bit. If they're older, they might want to say they're younger, and if they're really young, they might want to say they're older or something. You're just wondering if that's the case, and if maybe there's a lot of error in your measurement and that it's not very valid. Well, a way you could test that to find out is ask people how old they are, and then gain access to their birth certificate records and match up the two and see how accurate people are in telling you an age that match up with what the records say. See, so here but I use this term criterion because the birth certificates are sort of the standard that you're kind of assuming that the birth certificates are accurate. You're saying, okay, this is kind of an established, this is a variable, a measurement data that we're not really questioning. We think these birth certificates are generally accurate. So that's going to be our standard against which we're going to compare what people tell us in an interview. And we're going to see if the two match up. If they match up really well, say 99.9% of people give an age that matches their birth certificate record, then we're going to say, okay, now we've kind of established criterion validity. We now have greater confidence that what people tell us is accurate. It's hitting the target, hitting the bullseye based on this criterion. Again, remember the criterion is the well-established measure, uh, the one that you, for the purpose of this study, that you trust. And in this case, it's the birth certificate records. Okay, that's criterion validity. So it's just one thing that we do to check to see if we think our data is good. Now, concurrent validity, the extent to which a new measure correlates with an established variable measured at the same time. So it's a little bit like criterion in that you've got a new measure going measured against the established one, but here you're concerned about, am I measuring something accurately for a particular time, right? For a particular time. So I measure heart rate. We use the typical techniques and check your pulse and measure your heart rate. And then, because we're wondering can people tell roughly if their heart's beating fast or not, you know. And so you could, maybe it's crazy, but you could ask people and say, hey, estimate what you think your heart rate is right now, just based on how you're feeling and your sense of whether your heart's racing or you're relaxed and it's beating slowly. So they give you an answer, and then you match it up with an actual, how we normally measure heart rates, would check in the pulse, and like how a medical professional would do that, and you see if they're how accurate the person's perceived heart rate is. And maybe it's inaccurate, maybe they're way off, and you'll learn that, wow, this is not going to be a good way to ever measure heartbeats, because people just don't have any clue how hard they're fast their heart is beating. So see, but it's a test, but it's the key thing here is that you want to know how fast that heart's beating right now. It's about, right, concurrent means happening at the same time. And so, you might want to, another example would be, we want to know if we give you one of these standardized tests or something that you have to take when you're in school, and we want to see if that's a good measure of what you're learning in class and what you're learning in school. It's standardized, so you're wondering, well, is it really measuring what students are learning? So maybe you would compare the score on a standardized test with your grades from your classes, how well you're doing in your classes right now. Those grades based on a lot of things, but based on your classes, do those match up with the standardized scores? If they match up with the standardized test scores, then that's like evidence that, okay, it's like the student's performance right now this semester matches up. The test scores, the standardized test scores, look very consistent with how they're doing in class, and so therefore these standardized tests looks like they're pretty valid, because they're matching up with some reality like they're supposed to, how the student is actually doing in class, and that they're matching up at the same time in the same semester. So concurrent means same time. So you got to keep that part in mind. Hopefully that's clear. If any of this stuff, some of the stuff is a little tricky and vague or abstract. If any of these things that you don't get that I'm talking about in video lectures, please reach out, email me, ask for clarification. We can always do Zoom meetings, or bring it up in class, and we can go over it in class too. So don't hesitate on that. Predictive validity is like concurrent validity, but there we're looking at predicting the future. So this is what a lot of times these college entrance exams like the SAT, the ACT, are trying to do, is you take a test before you go to college and they give you a score. And the predictive validity is, how well does that score predict how well you're going to do in college? If you get a high score on the ACT, and people who get a high score on that always do well in college, then it has high predictive validity. If there's not much of a correlation, if your score on the ACT or SAT doesn't predict accurately how well you're going to do in college, high scorers often do poorly in college and low scorers often do well in college, well, that would be evidence of low predictive validity. It doesn't predict the future well. So either it does or it doesn't based on the data, right? But that would be a test, is does your measure predict for the future what it's supposed to predict? And so it's a test of future behavior or future performance. That's the difference between predictive and concurrent, is just the time element. You just remember that. Concurrent means now, and predictive, of course, referring to the future. Now, content validity, the extent to which an individual test items are correlated to construct the full range of the construct. So this one's a little more technical, but it's not as difficult as it sounds. Look at the example here. Do individual IQ questions correlate with the overall score, and do they cover all aspects of IQ? For example, verbal IQ, quantitative math kind of IQ, et cetera, et cetera. So content validity is, there's at least two things that are going on there. And that is, are your individual questions, then and this is very often, you don't ask just one question, like when you take an IQ test or just a regular exam in class. You don't just get asked one question, you might get asked 50 questions or lots. So what they're getting at with content validity is, are there some questions in there that are bad? And there are some of the questions good. So you need to throw out the bad ones and keep the good ones. Well, how do we know that they're bad or they're good? Well, if you have a student who just totally aces the exam, let's say you've got 10 students that totally ace the exam, but there's like 5 questions that all of those excellent students missed. All the best students are missing these questions. That's evidence that those questions are bad, that they're worded poorly, that there's something wrong with them, because your best students are all missing the same questions. What's up with that? So that's an example of how you would measure content validity. It's a way of detecting bad questions so you can get rid of them, or good questions so you can keep them. But then the other part of this here that the definition here, the description gets at, is if you're going to ask a whole bunch of questions to measure something, are you covering all the bases? Because, for example, maybe IQ is a very broad thing that involves lots of skills, or there's different types of intelligence or different types of skills. And are you covering all the bases? Or are you measuring something narrow and just 1 or 2 things when really you should be measuring 5 different things? Verbal intelligence, math intelligence. I don't know what other things you might want to put in there, right? Other things that you might think belong in there. Are you covering the full range of what it is you're trying to measure? So content validity really refers to something we'll talk about later in the semester, where you try to measure what you're studying with a lot of questions, not just one question, with like a whole bunch, like when they give you a personality test, or any sort of test with lots of questions. This content validity refers to all of those questions. Are they good questions? Do they cover everything or not? Okay, that's what content validity means. Now, let's see. The 2 major types of quantitative research. Correlational research, number 1, where you analyze the variation that occurs naturally in the world. And then number 2, experimental research. One variable is manipulated under controlled circumstances to identify its effect on another variable. So yes, these are the 2 major categories of research that you see that we do, quantitative research, I should say, that we do in the social sciences. Most of it is correlational. So what do we mean by correlational? Well, let's say that I'm interested in looking to see if there's a correlation between substance abuse and acting violently. If people who are abusing drugs have a higher risk of acting out violently than people who don't abuse drugs. And so what do? I get a sample of people. I ask them, do you have a problem with drug use? And, however I measure that. And then I also measure and see if they've acted out violently. And then I correlate and see if the people who say that, yes, they've struggled with drugs, or they use too much drugs, or they have a problem, something like that, do the people who say that, are they more likely to have acted violently over the same period of time, say the past year or something? And the people who haven't abused drugs, are they less likely to have gotten involved in violence? See, so it's a correlation. And that's the bread and butter. That's how we generally do research in the social sciences. The one really big exception to that is that you see in psychology a lot of experimental research. And there it's in a lab situation, a controlled situation, where I give one thing to one group of people and another thing to another group of people. I mean, otherwise the 2 groups are exactly the same. But the classic example of this is a new medication, a new pill that's going to fight some disease, maybe some pill that's going to be able to reduce COVID symptoms or something like that. So you have 2 random groups of people randomly selected. You give the pill to one group of people to see if it reduces what COVID symptoms they get over the next 6 months or something. And then the other group, you don't give them that medication. Maybe you just give them a sugar pill, a pill that's just a fake pill that doesn't have any impact. You give it to those people and watch their symptoms, COVID-like symptoms over the next 6 months, and you see if the people who took this new medication, if they have fewer COVID symptoms over that period of time. If you do find that they have significantly fewer symptoms, or catching COVID less often or less seriously, then that's evidence that the pill's working. So that's experimental. You're doing this manipulation, in that what we mean by manipulation is you give something to one group but not the other group, and the 2 groups are the same otherwise, and you see if you get differences as a result. So that we do that less in sociology, social work, criminology. We do some experimental methods, but it's less common. Most of the time we rely on correlations, and that's Correlations is what statistics is all about. That's why you have to take these statistics courses, is that the research that we do generally is correlational and relies on these looking at the connections between this variable and that variable. And so that's what we focus on, and we will focus on this semester, is this correlational research. Okay, so I think I will stop it there.